Hello, dear viewers. Welcome. So, I was having a question. Is it important for a structural engineer to know how many bags of cement he requires or are going to be used to cast, whether it is slab, beam, or footing for foundation, or the entire project? Yes, it is important for structural engineers to know the quantities of materials and especially cement because it is very expensive, which are going to be used during construction project. So if you ever going to get a task to manage a project, you need to know how many bags of cement you are going to need, and you need to know for that matter how many bags of cement are required for 1 meter cubic of concrete. So if you know how many bags of cement are required for 1 meter cubic of concrete, then for sure you can know how many bags of concrete you're going to need to design to cast an entire slab or to do an entire project. So that's my focus in this video today. So let's begin. So first of all, the most important thing to know is the class of concrete which you are going to use. So you can either have class 10, that is M10, or class 15, that is M15, or class 20, that is M20, or class 25, that is M25. And you need to know the ratio. So for class 25, the ratio is 1 is to 1 is to 2. For class 20, the ratio is 1 is to 1.5 is to 3. For class 15, that should be 1 is to 4 is to, that is 1 is to 2 is to 4. Okay, that is 1 is to 2 is to 4. And then for class 10, the ratio is 1 is to 3 is to 6. So for this project, for our project here, we need to use class 20. So I'm going to focus on class 20 of concrete. So I assume that you already know these classes, and what we need to know is how many bags of cement we need in a project. So we need to know how many bags of cement we need in 1 meter cubic of concrete based on the class that we're going to use. So to do that, the first thing you need to know is what does this ratio mean? This 1 is to 1.5 is to 3 basically means 1 bag of cement is 1.5 sand and 3 ballast. So for each 1 cement, there is 1.5 sand or smooth aggregate and 3 coarse aggregate or ballast. So when you already know that this ratio, you need to know that if you add water into cement, or put cement somewhere, a whole bag of it, add water, and then put it back in its bag, the volume will not be the same because cement will have absorbed the water. So there will be what we call shrinkage. So we have to include to use 50% expansion factors when we are doing these ratios. So because when you add water to cement, it is going to shrink. So per each cubic meter volume of cement, there is 50% extra volume. That is, there's 50% extra volume. That is 50 over 100 extra volume. So the new volume will now not be 160 cubic meter. It will be now 1.5 cubic meter, or just like that. Okay. So after you know that, the other thing is to now add the summation of this ratio. That is 1 plus 1.5 plus 3. So for class 20, the total sum for this ratio is equals to 5.5. Okay. So now, out of 5.5, there is how many meter cubic of ballast? So of cement. So for out of these, because there's for this one we have added another, for this 1 meter cubic of cement, you have added an extra 50% due to shrinkage. That is an expansion factor of 1.5 or 50%. So the new volume is 1.5 meter cubic. So how many what will be now the new volume for cement? So the volume will be, let me wrap all of this. So it will be 1.5. We need to find the number of kgs of cement in 1 meter cubic of concrete. So that will be 1.5 over total sum, which is 5.5 of the ratio, multiplied by, now this one will be meter cubic, multiplied by the density of cement, which is 40 kgs per meter cubic. Okay, that is 40 kgs per meter cubic. This is the density of cement. Okay, this is the density of cement. So you know that in class 20 concrete, in 1 meter cubic of class 20 concrete, there is how many kilograms of cement need. So multiplying this ratio, we'll find that. So let us use our calculators. That is 1.5 over 5.5 multiplied by 14 volts. So in 1 cubic meter of concrete, there is 392.72 recurring kgs of cement. Okay. So having that, you know that 1 bag of cement is 50 kgs. So 1 bag of cement is 50 kgs. So let me wrap all this. So 1 bag is equals to 50 kgs. What about 392.73 kgs? So you cross multiply. So by cross multiplying, we find that the number of bags of cement will be 392.73 divided by 50, which will be equals now to Using our calculators, 392.73 divided by 50 will be about 7.85. That is 7.8. So we know in class 20, in 1 meter cubic, 1 cubic meter of concrete, how many bags of cement? 8 bags of cement. Okay. So we can now rub all of this. So how many bags of cement are required to cast this slab? So it's very simple. So what you need to do is to take the plan for this slab which is being casted. So you go to Aggregate. So this is a 2-bedroom. Is this one? We already have the plan. You import it into Aggregate, whether it is in PDF or DXF. You import it into Aggregate, and then you find the total area which is going to be covered by this slab. So we want to know the output during this day. How many cubic meter, how many bags of cement were used to cast this ground floor slab. So you can see these spacers which are 100 millimeter, and the slab should have a clear cover of 50 millimeter. So it means that the slab is 150 millimeter in depth, that is 0.15 meter. So we just need to find the area and multiply with the depth, find the volume. So I'll go to Aggregate. I import this. The next thing I'll do is to scale. I will scale this drawing. So I know that the distance, the total length from this grid here to this grid is 19100. So I just go to edit, the shape, resize, and then okay, and then I'll just click here up to there. Okay. So let me first escape it. So I know the distance between here, this point here. First escape this. So we know that we need to scale this drawing, and we know that the distance between grid A and grid H is 19100. So we need to scale the drawing. So I just need to select everything. And then I'll go to edit, the shape, the size. So we have already determined that for each cubic meter of concrete, there are 8 bags of cement. So how many bags of cement are we going to use, or did we use to cast this slab? So we just need to do this. Let's first scale the drawing, make sure that the dimensions are accurate. So just hold Shift D and then type the distance is 19100, then enter. Now the drawing is to scale. You can go to design. You can go to your design tool here, select your zone tool, and then we'll select the entire zone which will be covered by this slab. So from this point, as you can see from our drawing, from this one, you can see where the beam for this slab has been located is towards the edge. So the entire zone is being covered with a slab. So the entire zone was casted on this day. So I go from that point So let me first select. So I'll go from this point here. Yeah. So make sure it's polygon because the shape is not rectangular, it's a polygon. So that is select the first choice. Then I can select the entire zone which is covered by this slab. And you can see the beams were being, the formworks, where the formworks were being uh, done. So they are on this edge. Uh, the formwork to this slab. So you can see, let me first finish this one. This is the entire area. So Aggregate is a very useful tool for structural engineers. It will help you in many areas during your career. So up to there, up to there, up to there, up to there. So we are covering the entire area which is going to be, the slab is going to be casted based on the formwork as we see it on the ground. So that way we can be able to determine the output. Then back there. And then you can just click anywhere inside. So I'm going to click at the midpoint. This is my entire slab. The entire area that will be covered or was covered by these concrete is already given, that is 219.063 meter square. So you don't need to go. So I can just change the dimension. Change concrete to ground beam slab. Ground floor slab. I can just change the name. This is concrete to ground floor slab. Is covering an entire area of 219.063 meter square. So after that, you can be able now to determine the volume of concrete used in meter cubic. So we know that the total area covered by the slab, ground floor slab, is 290.063 meter square, and we know that the depth of the slab is equals to 0.15 meters, that is 150 millimeters. The total volume will be 219.063 3 multiplied by 0.15. So find that the total volume will be around 39. So let's do the math. Multiplied by 0.15. So the total volume is 2.85. 86 meter cubic, or 32, just write whichever way you want, cm, that is cubic meter. So knowing that, and we know that for every 1 cubic meter we need 8 bags. What about for 32.86 cubic meter? So we just need cross multiply. So I find that the number of bags of cement required is 2.86, that is 32.86 multiplied by 8, which will give us 2.86 multiplied by 8, which will give us around 263 bags, that is 262.88 bags, that is 263 bags, because we don't have point something bags. So we need 263 bags for that slab only. Okay. So let's say you are doing a rough foundation. Let's say you are doing a rough foundation. A rough foundation, as you can see here, or a combined footing with dimensions of, let's say, let me delete just this one. Dimension of 6 meters by 4 meters. So you just need to go to zone 2 in Aggregate, then just select. I can just even select rectangle, then just select my entire zone, then click inside. You can see it is 24 meter cubic. So 24 meter cubic, 24 meter cubic times that is 24 meter square times the depth of this foundation. So we find that the depth for this is maybe about 500. So what is the volume? It will be 24 multiplied by 0.5. So the volume will be 24 multiplied by 0.5. The volume will be 12 cubic meter, that is cm, whichever you put it. So after find this volume, we know for each 1 cubic meter you have 8 bags. What about 12? It will be 12 multiplied by 8. How many bags now? That will be around 96 bags. Of cement will be used in this rough footing. So that is how you determine the quantity takeoff for concrete on site. So you can be able to plan on the cost You can able to prepare your BOQ, and you can also be able um, to do what you call to determine the output on site. Okay, because for a structural engineer, if you are or you're on the site, you're the one in charge of the site. You need to determine the output so that you know that the materials that are coming in and the materials that have actually been constructed are matching up. Okay, so that you can be able to easily do the math and to know that everything is going smoothly. So, guys, that will be it for today. I will see you in another video. Thank you so much.